Advent of Code is back. This year, it's just 12 days of programming puzzles where you get 2 puzzles every day. The first one is a simpler version of a problem, and the second one is a more advanced version. If you haven't done Advent of Code before, you can check out my previous video where you get started and you will learn how to register and get started with your programming language to get solving these problems. But because it's December 1st, we can start already with the first problem of this year. So I will go here, and the first problem this year is actually about unlocking a secret entrance. The elves have a special lock that is a rotating kind of lock where you start pointing at number 50, and then you get a set of instructions how you have to rotate the dial to the left or to the right. The problem is that to get the actual password, you need to figure out how many times the sequence ends up at pointing at number 0. So in this example, where you started pointed at 50, you rotate first to the left by 68 points, then to the left by 30 points, then to the right 48, and so on. And every time you stop at 0, you count it. And the number of times you stop at 0 is the actual output of the problem. So that's simple enough, but there's an important caveat that you need to make sure that you know about, and that's when you rotate to the left from 0, you end up at 99, and when you rotate from right to the right from 99, you end up at 0. So this is the kind of situation where you overflow or underflow, and you have to take the remainder when you divide by 100. Basically, it's a division remainder problem where you either add or or subtract a number, and then you do modulo, so you can calculate the remainder after division by 100. So that's what we are going to do, and I have already my prepared problem here, so I can start solving it. So I will get the lines of the input, and then for each of the lines, I will actually do a counter, which will be the counter of number of times I hit 0, and I will do current location, which is going to be 50. So now for each of the lines, that's not what we want. So for each of the lines, I will actually take the direction, which will be the line 0, 0, and if it's equal to the left, we will do -1, otherwise we'll do 1. So basically, this will give us the direction in which we should add up the number. And the second number is the distance. Yeah, that's exactly what it's just here. So I will do the distance, which is the number except for the first character, and I will parse it into int. So what I will do now is do current, so we'll do current location equals direction times distance. So plus equals direction times in distance, and then I will have to make sure that the number is divided by 100 and the remainder is stored. So I will do modulo equals 100. So it will divide by 100 and get the remainder. So if now the current location is equal to 0, then we will add it to the counter. So plus plus the counter. And that's it. So hopefully this should be enough. So I can return the counter, and hopefully that will be the solution to this problem. So I have already prepared the test data here. So that's the test data of the problem, and we'll see if this will be a good result. So it gives us 3, which matches the expected result for the test data. So I will run it with the input, and let's see what happens. So it's 1165, and that's correct. So we have the first part of the problem solved now, And let's continue to the second part. This will be the more advanced version of the same problem. For the second part of the problem, we are supposed to figure out how many times we go around 0 or end up at 0. So not just when we stop at 0, but also when our rotation goes and passes through 0. So that makes it a little bit more complicated, because we need to make sure that we not only count when we go around 0, but if we do a rotation that goes full circle, and we need to count how many times we go full circle and add up those times. So that gives us much more different potential combinations that we need to take into account. So what I will do here is that I will adjust our current implementation to account for these. So what we have here, one first thing that I have to fix here is that our current location, module 100, can end up being a negative number, because in C# these numbers can underflow 0 and stay in minus values. So I will go and fix this. So I will do current, if current location is less than 100, less than 0, then I will just add up 100 so that we always end up in the actual dial numbers. So that's one thing that is worth fixing. But now let's figure out how we can calculate the correct number of times we pass 0. So if we do more than 100, if we rotate in one direction more than 100 times, we should calculate how many times we did it. So full rotations. So we can take the distance and divide by 100, and those full rotations are actually the number of times we go through number 0. But this makes this we have to think about the times where we actually start at 0 and go back to 0. So if we are at number 0 right now and do 100 to the left, we end up back at 0. So it will count the number of 0 here once as one full rotation, but also we end up at 0, so we would count it for the second time there. So we need to figure out, so we can do like a start location, that would be a current location, and we should check if the start location was if it wasn't 0 and now it's 0. So if we actually changed to 0 from something else, then we add up to counter. Otherwise, if we do the full rotation, we would count it already here. So that's this. And now to calculate the actual distance that where we actually end up, what we can do, because we do some full rotations, but also do some partial ones. So we now need to know if we, during the partial rotation, we also went through 0 or not. So what we can do here is to see if current location is less than 0 or current location is greater than 99, or I mean actually greater than 100. So if we pass 0, and if we didn't already started 0, so start location is not 0. So basically something like this. So if we didn't start at 0, but we passed through 0 during the rotation, then we should also add up to the counter once. So basically count the number of times we do full rotation. That's one addition to the counter, or actually addition by the number of times we do the full rotation. Then the second time we check if the partial rotation that remains after doing those full rotations also passed through 0. So we didn't start at 0, but we did we go to the left or to the right from the 0. And finally, well, this actually cannot happen, right? This cannot happen because we always modulo by 100. So technically, this is the condition that we want. So if we go under 0 by the partial rotation, oh wait, we have to make sure that this is correct. So because if we are at current location, we add up the distance. So actually what we can do is do distance modulo by 100. So because if we rotate to right and we're at 99 and we rotate to the right by 1, then we should count it. So it should be like this, I think. That should be more appropriate. So if we start at the location that's not equal to 0 and we have a number that's less than 0 or that's greater than 100, then we passed through 0 on this way. So we add it to the counter. And finally, we also add it if we end up at 0 and we didn't start at 0. So that should be hopefully the right solution. We'll see what happens if we run it against the test data. With the test data, we get 6, and the expected number is 6. So we'll see if this works with our input file as well. So I'll add an input file and run it with the input file, which gives us 6,496. And that is right. Okay, so we've solved the first 2 puzzles of this year. And okay, so that's it for the first day. I will be back for the second day, and I will see you next time. Bye bye.